Mathematical Practice 3. Construct viable arguments and critique the reasoning of others. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. This webcast will highlight Mathematical Practice 3, construct viable arguments and critique the reasoning of others. So, to begin to get a sense of Mathematical Practice 3, construct viable arguments and critique the reasoning of others, let's consider a scenario outside the math classroom. In today's media-rich environment, messages are coming at us almost constantly through social media, television, movies, online videos, blogs, billboards, newspapers, magazines, books, and radio. We are given ideas about who to vote for, what to buy, what to care about, and how to think. As we take in all of this information, it is essential that we are able to critique the reasoning of the messages that we are given and make sure that we are constructing viable arguments as we formulate and share our own views. What support does the speaker or writer have for their message? Is their reasoning logically sound? How do their ideas fit with our own experience of the topic? Are there examples or counterexamples? One great place to practice asking these critical questions is in the math classroom. As our students construct viable arguments and critique the reasoning of others, they are practicing the thinking and communication skills that they will use to think critically in other academic areas, at work, at home, and in the community. Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to construct viable arguments and critique the reasoning of others. I'll highlight 3 features of this mathematical practice, as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. When you work with Mathematical Practice 3, you'll be guiding your students to support conjectures with mathematical reasoning, uncover and explain a flaw in reasoning, and ask and answer questions to clarify arguments. To encourage learners to support conjectures or unproven statements with mathematical reasoning, you could ask them, "How did you know that?" Or, "Could you explain your thought process?" For example, at a lower level, students could discover the commutative and associative properties of addition by testing various conjectures about a list of numbers to be added. Students may wonder, is 3 plus 4 plus 7 equal to 4 plus 7 plus 3? Or is it okay to group the 7 and 3 to make 10 and then add 4? From these questions, students can make and test conjectures. If a student believes a conjecture to be true, that student would need to support the conjecture with reasoning and examples. One way to practice supporting conjectures is with the activity always, sometimes, or never. Make a conjecture like, when adding, order does not matter, or when subtracting, order does not matter. Ask groups of students if it is always, sometimes, or never true. Remember, they will need to support their conjecture with reasoning, examples, or counterexamples. At a higher level, to practice supporting conjectures with mathematical reasoning, students can use probability models to explain the likelihood of an event occurring. They can make a decision that is informed by probability models and explain the reasoning behind that decision. For example, the local high school is selling raffle tickets for a fundraiser. To win $1,000, tickets cost $5 and 1,000 tickets will be sold. To win a sweatshirt, tickets cost $1 and 1,000 tickets will be sold. To win a season pass to all basketball games, the tickets cost $10 and there are 200 tickets to sell. If you wanted to spend $20 on raffle tickets, which combination of tickets would you buy? Use your understanding of probability as you explain your reasoning. By encouraging learners to support conjectures with mathematical reasoning, you'll see them focusing on the why of their answers. Now let's continue to the second feature. To encourage learners to uncover and explain a flaw in reasoning, you could ask them, "Do you agree? Why or why not? Is there something that doesn't fit with the way that you understand it?" For example, think of common mistakes that students make when working with fractions. Share that mistake with your students. Ask them to use reasoning as well as a sketch to show that it is indeed a mistake. Where is the flaw in the reasoning? The same activity could be done at a higher level as students learn the meaning of exponents. Ask them to show that this is indeed a mistake by using reasoning and examples or counterexamples. Notice how your brain engages in a different way when you are looking for the flaw in reasoning rather than looking for the answer. By encouraging learners to uncover and explain a flaw in reasoning, you'll find that you will see them critically analyzing their own thought processes. The third feature of constructing viable arguments and critiquing the reasoning of others is encouraging learners to ask and answer questions in order to clarify arguments. To encourage this, you could ask, "How did you arrive at that conclusion? At what point does my explanation not make sense? What question do you have?" For example, at a lower level, students could sort pictures of shapes into categories. As they work through the exercise, they can ask questions and explain their reasoning as they decide where to place each shape. This is a great opportunity to practice using precise vocabulary. At a higher level, students could use arguments based on the number line, a bank account, stairs, an elevator, a thermometer, definitions, or another model to clarify arguments about combining integers. When students disagree about an answer, they can ask and answer questions to make sense of the combination of integers at hand. By encouraging learners to ask and answer questions to clarify arguments, you will see them engage more actively in the learning process. Each of the previous examples illustrates how students could construct viable arguments and critique the reasoning of others. Now let's watch these middle school students construct viable arguments and critique the reasoning of others as they correct another student's homework.
Do you think it's accurate?
I don't think it's accurate because she never really got the answer. She never got it correct. She would have been close.
Well, if she kept going, she would have got the answer.
Today's lesson was a wrap-up of linear equations. They looked at two other students' work, and they got to see some mistakes that they make on a regular basis and what effect that has on the problems. They also got to see different approaches to the problem and which ones might be more effective than others.
It sounds like it's halfway efficient.
So she's on the right track.
Well, she never got the answer. No, keep it like it is.
Because if the answer...
Well, that's for 3x equal y. Just for that problem. But what about over here?
She's plugging different numbers into here and then plugging those numbers into this equation to see if that'll work. See? 1x, 3y, she plugged that in.
Yeah, she plugs it into the
2,
equation.
plugged in.
Look, I use
So that's what she's doing. She's solving this
Just
and
set
it
up like
works
a
in here.
table.
Yeah. You can see if all the students' work that we're correcting, they all make the same mistake. You can like make sure you go back over your work because I think it was Ethan, one of the problems. He, instead of subtracting a number, he added a number and it messed up his whole thing and he didn't go back and recheck it. So he got the entire question wrong, even though he did his processes right. These are the original equations. I think
You know what he did wrong?
the only mistake
He
was he didn't.
substituted y as this.
Yeah, no, that's right. Because
Yeah, he
x
No, because
x equals y over 3, and they substituted that in
oh
for
yeah.
x. So this is in parentheses. And what I think he messed up, he never multiplied the 4.
I was thinking he
right here.
substituted this in for y because I didn't
Yeah.
see y at first.
I think he didn't multiply that by 4 and that
he
by
just kinda
3.
put it down
yeah,
there.
he just multiplied that part and that part.
All right, so is his work clear?
No.
When it wasn't them doing the problem themselves right then, and they're looking at somebody else's work, they could say, oh, they made this mistake, they made that mistake. I don't like how they organized this. It kind of gave them a reference point about how to make their own work better.
We had to figure out what he was doing. If we had to do that, then it's not clear.
Is it accurate?
No.
How did the students in the video construct viable arguments and critique the reasoning of others? Did you see them support conjectures with mathematical reasoning? Did they uncover and explain a flaw in reasoning? Did you hear them ask and answer questions to clarify arguments? All three features may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The students in the video were asked to analyze the work of another student and answer specific questions about it. Looking at the work of other students is an activity that would be meaningful and engaging at all math levels. You could share work from different classes, or you could invent a student who makes common mistakes. This activity will give students an opportunity to focus on their reasoning process without worrying about getting a right or wrong answer. In conclusion, I want to remind you that Mathematical Practice 3 gives students so many opportunities to talk about math. When students are talking about math, they are actively engaged in learning math. Here is a poster that summarizes Mathematical Practice 3. The next slide shows the link where you can download the poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to construct viable arguments and critique the reasoning of others?